I'm going to talk about my journey to the dark side. Welcome to my channel. I focus on tabletop role-playing games, video games, and science fiction. In one of the comments to my video on the Strategic Defense Initiative, Jeff Childers asked why or when am I going to do a video about my journey to the dark side? What he's talking about is I originally started off with math and physics, and how did I end up where I'm at right now? And I'm going, this is just sort of bizarre, and I'll talk about it, but it's to give you a little idea. So if you don't, I will be talking about some things. If you're not into math and physics or whatever, hopefully it's a humorous story. To me, it's a fun story. It's my life, and so I'll talk a little bit about my life. So, I wrote some notes down so I get everything that I wanted in this one. In the summer between my junior and senior year in high school, I was given a scholarship to go up to the state university and take part in their summer enrichment program, which meant you had to take this course, this engineering course, and you could take any other courses that you wanted up to a full load. So, what did I do, of course? For me, I, of course, signed up for intensive calculus. Okay, so here I am, a junior in high school, and I go into this course, intensive calculus. Interesting introduction into college life. And this course taught 1 year of calculus, gave you 1 year of credit to complete during the summer. Courses, it was, I think, 3 hours each day, 3 hour courses, class, which is kind of intense at college. And you're going through, and it was an intensive, it was intensive. You come out with actually multiple letter grades. I aced the course. So, this caused my senior year to be in high school to total disarray because I had planned on taking AP math, but now I had more credit, college credit, than the AP math test could possibly give you. So, after some fighting with counselors and so on, I actually get arranged to do what's called release time, so I could go to release time to go to the university. So I was driving up to the state university and taking my second year of calculus. So I actually took my second year of calculus in my senior year of high school. So I was going through that, and I finished that course. That was a lot of fun for me. I enjoyed it. So I had 2 years of calculus by the time I graduated high school. Now, I'm going to skip over a bunch of things that happened, but anyway, my major was math and physics, or physics and math mainly is a better way. And the physics department actually gave me a job. I was working in the physics department writing software. I got wrapped up in a project called Video Computer Instruction System. They were teaching physics courses and so on, and they're building up the software to do teaching different things about physics. That was what its primary focus was, but it could be used for other things, and some other people were using it for other things too. So I was working for the physics department, going to classes, and one of the professors in the physics department leaves unexpectedly. And I don't know all the politics about it, but he left with no warning, giving the college no warning, just before the new classes were going to start. And so the physics department had to scramble. They're trying to figure out, what are we going to do? We have this course that we have to find a different professor to teach it, and the professor had not laid on textbooks or teaching assistants. And so the other thing that we didn't realize was that the professor, I'd actually had a course from him, and he wasn't a very easy professor to listen to. I mean, his teaching methodology was a bit of a problem. He was just sort of boring. I remember him getting upset at our class because I was taking the course, and the course was taught in a room that was a stuffy room in the physics building that was, and we had it right after lunch. It was right after lunch, and the room was hot and stuffy, and he's teaching the course, and everybody is yawning, just everyone in the class, and he got mad because it was there. But anyway, he left. So they find one of the professors that I'm actually working for. He gets picked to teach this course. Now, this course is physics of instrumentation, and it's part of the master's program of physics of instrumentation. The course is computational physics. And so the master's program is a little unusual. When you go into physics, normally you're going to go for a PhD, but there was a master's program that was for people who didn't want to go all the way to a PhD, but they were going to go into instrumentation, which is a complex topic all by itself. So we were going to be going through the course. So what happened was the professor that I was working for picked me and says, you got the math background, you'll be the TA. So here I was, an undergraduate, as the TA for a graduate level course. A lot of fun. So anyway, I'm grading papers. I'm still working, but I'm grading papers. I'm also going through and doing demonstrations in course and teaching how to use the software libraries that we developed for them to write their software. So anyway, that was an introduction to the weirdness about, as an undergrad teaching that, and I was into computational physics. So at the time, the math, physics, and chemistry departments all were teaching computer science courses. They were always co-listed with the computer science department, but it was that the math, physics, and chemistry department sort of viewed the professors in the computer science department with derision. They didn't think they know what they were doing, and they were teaching how to solve physics and chemistry problems mathematically, because there were times when you needed to do computational physics or computational chemistry where you're doing these calculations, and it requires a very meticulous approach to doing this type of software development. And so I ended up getting wrapped up in taking a whole bunch of courses. I was the math department was teaching. They were teaching graduate level courses in computer science. They were co-listed, but I never took them. None of my credits on my transcripts have any computer science courses. This is sort of humorous to me because if you understood what my position was and what I do for a living, this is sort of humorous because I've never taken a computer science course. Now, let me clarify that. I was a young man and I decided to, I actually signed up for one of the freshman courses in computer programming because I was looking to pick up ladies. That didn't work out well, and I actually dropped that course. So I did sign up for one, but I never completed that. I was just, no. Anyway, I was taking doctoral level courses in computer science, and in computer science and math. And so we're there. And the reason that these courses were listed under a math department, they were dealing with graphics. And I don't know if many of you really understand what's involved in the low-level computer graphics stuff. Most everything that you're actually doing when you're really doing in 3D. It's all hidden. Few people ever get down into the guts of what's actually happening and how ray tracing works, or how all the real software. It's all integration. Everything that you're doing is a form of convolution, which is a form of integration, because you're integrating over space. And aliasing, actually arguably, is a form of integration. And your GPU on your computer is actually doing vector calculation. So you're always doing vector and tensor mathematics, but you don't really realize it. Most people don't realize what's down there. And that was the thing that was being taught from the math department, was how to do this. And they were actually the computer science people who, unless they had a heavy background in math, were having a real hard time with the math. And the math majors were actually having a hard time with the computers, the programming. So I was talking about the doctoral courses that I were taking, the doctoral level courses that I was taking. The problem that they were seeing was that the math majors had a problem with programming, and the computer science majors had a problem with the math, because it does get fairly heavy, and you're doing vector and tensor calculations with to do the low level graphics calculation. Because if you're down at the GPU level, what it's actually doing is it's doing vector calculations. That's why, and it's all floating point operations and doing the calculations. And to understand how that actually works, you have to have a fairly heavy math understanding, a fairly heavy math background. Today, with the, like Unity and the other libraries, you can actually do the graphics without understanding what's under the hood. You don't really need to get down into the under the hood and do that, most people. But I've been down doing some of that, and it was interesting. I enjoyed getting down into there. So anyway, I was taking some courses with some very high level courses with computer graphics. Anyway, some time passed, and I get my first real job, shall we say. Not working for the university. So I go to work for a company that is writing software to teach algebra and calculus to high school students. And for those of you who've ever seen Wolfram's Mathematica, we were working on software, this is many years ago, that was somewhat comparable to what that does. Now, Wolfram's Mathematica can integrate and differentiate into a whole bunch of other things. Our software wasn't quite that mature, but we could integrate and differentiate equations. So what happens is you would type an equation in. The equations would, we would run through the symbolic manipulation, and actually we could integrate or differentiate the equations. But we were trying to check this. So what would happen is that my job for the first 6 months I was there you'd come in the morning, you would pull up the book, a table of integrals or differentials, and you would type an equation into the system. You would then, the computer would think for just a second and spit back an answer. You'd write it down, and then you'd spend the rest of the day trying to see if that matched the answer in the book. And most of the time it didn't. But what happens is you needed to understand how to do the algebraic and trigonometric substitutions, because the answer from the book may be different. But it also pointed out something that most people aren't even aware of, and that is at least 10% of all the answers in textbooks are wrong. Okay, I have 2 books I have to recommend to you if you want to learn a little bit more about that one. The first one is Surely You're Joking, Mr. Feynman. And the second one is What Do You Care What Other People Think? Both of those are semi-autobiographical about Richard Feynman. Now, Richard Feynman is he is just an amazing, he's passed away, but he was an amazing physics professor. And tell a tiny little story about him. It's in the books, but you got to read this. So Feynman, at 18, has a doctorate in physics. And this is before World War II. And anyway, he's married. He actually gets married very young to the love of his life. And but Feynman works on the Manhattan Project, goes to Los Alamos Laboratories and is working on the Manhattan Project, and his wife gets sick and passes away. But here he is, he comes back, he's 20 years old, right after World War II. Mind you, he worked on the Manhattan Project. He's 20 years old, he's lonely, so he goes to a dance at college. I have to laugh because it's the way he wrote, the way it's in the book, but you gotta read it. It's hilarious. And he says, so he's in there and he's dancing with some girl, and Feynman is evidently danced quite well, and he's dancing with some girl. And the classic question, what's your major? And he asked the girl, and the girl, of course, asked the question, well, what's your major? And he goes, well, actually, no, I'm actually a professor here. And the girl looks at him, and she says, and then says, next you're going to tell me it's in physics. And he says, well, it is. And so she slaps him and walks away. You have to understand, after World War II, every company in America wanted to hire nuclear physicists because nuclear power was the big thing. So Feynman, at age 20, is a full professor in physics, worked on the Manhattan Project, and can't get a date because the ladies don't believe him. So you got to read the story. They're great books, but it talks a bit about the problem when later on, Feynman, with his children, he gets pulled in to evaluate textbooks. And Feynman, in his standard way he did things, they give him a textbook. He sits down and goes through methodically doing every problem in the book and shows how the answers in the book are wrong. The result was, I think it was to evaluate 5 texts. There were 5 textbooks, and so they sent him copies of 4 of them, and the 5th one they wasn't done yet, so they sent him a book with just empty pages. That was the book they ended up selecting because he had just ripped through what was wrong with all the other 4 textbooks. He said, no, that was what he was teaching math books. So, but it's the truth that most math textbooks have a high percentage of error, and it isn't even mentioned. I remember going to listen to a professor talking about why he suggested that he wanted all the books to run through Mathematica to evaluate their answers to see if they're right, because it's a problem in there. So anyway, some time passes. I'd worked at that company doing symbolic manipulation. Some time passes, and I end up at a healthcare company. And the key intellectual property of this healthcare company was a set of equations created by the founder. The founder had done a bunch of stuff about it. It was about respiratory therapy, and with these equations. They had a system, mini computer-based system, and they had they'd coded in assembler all these equations to solve this problem. You put in a bunch of information about the patient, and it would basically do an evaluation of how they were doing, how they were breathing, and so on. And it would help adjust the therapy for them based upon these equations. Interesting stuff. But it was, so they hired me. They want to rewrite their software for the PC. PC has just come out, the IBM PC has come out. So I'm in there. They were really proud. Their mini computer system, all handcrafted in the equations, all handcrafted in assembler, could solve the equations in about 30 seconds. Their preliminary prototype on the PC was taking like 5 minutes. So, being the arrogant type of person I am, I'm hired. I walk in and I take a look at these equations and a little bit of background on there, and I go, there's something wrong with these equations. Anyway, so I have to take the founder. He assumes that I don't understand them. And I go, no, that's not what I'm talking about. He's trying to explain. I says, no, that's not. These equations are not simplified. Well, what do you mean? Well, I said, well, here's just this term here, this term here. You can see that in the numerator and the denominator of the equation, we've got the same term. We can cancel them out and simplify the equation. And he goes, oh. And I go, I knew, I could recognize I'd done enough that what had happened was the equations were based on curve fitting. They'd got the data, they'd ran some curve fitting software, and it did a polynomial evaluation of the equations. It's a rational polynomial expression. And I said they're not simplified. So I spent about the next month going through the equations, simplifying them. I mean, in detail, written out page after page, showing how you simplify each equation. And this is, intense. And the founder is sitting there reading through every one, checking every statement that I'm going through. So at the end, we take a look at the equations. We've significantly simplified the equations. So now we start numerically. We evaluate them numerically, and we evaluate with the old method, the original equations, and the new method the new set of equations that I've simplified. And I go through and do this, and we do the error analysis, which is ugly to do. Error analysis is one of the things I really dislike, but we had to go through and figure out what the error was when we do these calculations and what the impact of simplifying the equations did on the error analysis. We come up with all this. So at the end, lo and behold, on a PC, I'm solving the equations in less than a second. And this causes a nightmare problem with the company because they'd figure that it was going to take minutes on the PC, which is now why would anybody buy their much more expensive mini computer system? So anyway, so that one, I had a bunch of fun doing that. Anyway, some time passes. I changed jobs a couple of times. And I'm ending up at another company. And I am really unhappy with the way software is being managed and the scheduling and the processing. And so I don't like what's going on. And I'm trying to figure out, and I started having a little bit of a question about my career. It's not exactly what I envision, but I'm evaluating my career options, and I'm thinking about, for those of you in software, there's, I evaluate, do I want to become a PMP, that's project manager professional, go and get my PMP certification, or I decide to turn to the true dark side. I go back and get a degree in business. So that's my transition to the dark side. And our last little story about business school, so business, and I'm in the course, and we finally get through I actually found the business more interesting than I was expecting. And I finally get this course on statistics. And I remember the professors going through, she's saying, okay, tell me what you think about this course. And all these other students are going, oh, I'm just terrified. There's going to be some math. And I go, I'm looking forward to this. This looks like fun. And the professor privately tells me, you shouldn't say that. These people have math anxiety. I go, what? Who cares? I'm sorry. It reminds me of Feynman's book, What Do You Care What Other People Think? And that's been sort of true in my whole life. I've got flamed by that. relatively recently by someone. What do I care what other people think? And you don't. I don't. So what happens is it's there. But my transition to the dark side, I went all the way from math and physics to business. But it took a long time, and I still enjoy sometimes doing some math. I'm older now, and I'm not as fresh of mind as I was when I was doing some of this stuff. I look back at some of the equations I've done, and I go, my career has basically been set because I was comfortable with math and physics. I was comfortable doing the math. That's where it got me into where I am arguably today. And it's sort of humorous that I tell people my degree is, I don't have a computer science degree. I have never taken a pure, it's a slight exaggeration. Like I mentioned, I signed up for a course once to meet some other ladies, and that didn't work out. But I've never completed any computer science courses. They were just computer science. And and I tell people that I've mentioned that a couple of times at work because my background is very different from average. And what happens is that I've been very methodical. One of the physics professors I had was, I learned how he did things, and he would pull down his lab notebook and record everything. And the way he tested software, the way he wrote software, the way he tested software. I'm not that methodical, but it taught me how you do things. And learning the math and physics and applying those principles to software development has been a very important consideration in my life. And I take a look at things, and it's like you look at it, gives you a very different perspective on systems and architecture than it does from, I guess, from most of the computer science courses, because you're looking at it as a problem, as a normal mathematical problem or physics problem or chemistry problem, that you have to approach it that way. And you realize that the key to solving any physics or engineering problem is the boundary conditions. Those are the key where, solving the equation with that. I remember doing that with the computer graphics, was you determining the area of the patch, or how when you're doing smooth surfaces, trying to do smooth surfaces in there. The patch is easy. It's the edges that make it complicated. And that's where you have to think about things, and that's where you have to do all the checks and the boundary. And that's where I learned about how to write unit tests, was basically you want to test it on all the boundaries. What happens when you pass a null parameter in? So that's into there something. Does your software handle it? Does your unit test record that, so that if you change your boundary? So my approach to software has been very different, and it's been influenced by my background in math and physics. But that's how my transition to the dark side came about. So hopefully that answers the question. I don't know why anybody would want to watch this one. It was fun. I've had a great life, and I work for a company that, as I've said before, I don't want to dox myself too much, but I work for a company now that I truly am because they supported me through the death of my wife and through going through cancer, going through chemotherapy. And I am very grateful for that, and have been very blessed with that. So thank you. Hopefully I answered the questions. Anybody has, love to hear some comments. This is sort of, telling a little bit more about myself and so on. So thank you for watching my video. I don't know why you would want to ever watch this one. Okay. I look forward to learning what you think about this video. Let me know in the comments below. If you like the video, press the thumbs up button. You can subscribe by clicking the link in the lower left. If you are interested, there are links to more content.